Okay, welcome to our day 2 of improper integrals. Today we're going to focus on improper integrals that deal with vertical asymptotes. So we'll either have to break up our integral into separate parts, or we're going to have to just integrate from the right side out of the asymptote or from the left side, and you'll just kind of see as we go through. So we have this function right here, an integral from 0 to 1 of 1 over x to the 1/3 dx. So actually I cannot integrate this because I'm not allowed to plug a 0 in. If I plug a 0 in, I'm going to get 1 over 0. So that's going to give me a vertical asymptote. So since I'm not allowed to plug in 0, and I'm going from 0 to 1, I am allowed to plug in a 0 to the right. So I'm going to have to be creative from this. So I'm going to go from a to 1 of this, let's call this x to the negative 1/3 dx. I'm going to find the limit as a goes to 0 from the right. Okay, I'm allowed to go on the right side of 0, but I'm getting as close as I possibly can, and that's why I'm integrating from a to 1. Okay, so now let's keep that limit notation with me. Antiderivative of x to the negative 3/2, or sorry, x to the negative 1/3 is going to turn into 3/2. X to the 2/3, integrate that from a to 1. So 3/2, I'll just put that out in front. I'm going to get 1 to the 2/3 minus a to the 2/3. Well, 1 to the 2/3 is just 1 minus, now again, let's plug in a 0 here. 0 to the 2/3, it's just 0 from the right side, but we still do a direct plug-in, and if there's any issues, then we kind of tweak it from there. If I do a direct plug-in, I'll get 0, and you get 3/2. So you're going to get 3 over 2 as your answer. Now, mathematically speaking, you could have just gone and integrated this and got the same answer, but it's actually mathematically not correct because you're not allowed to integrate from a vertical asymptote onto something. So that's why you have to use this notation. So just be careful. You got to be notationally careful on these problems. Okay, you'll get points taken off if you don't use the correct notation, or if you just assume, oh, I can just go from 0 to 1. Okay. So same type of problem here. Also going to have that vertical asymptote. So it's really going to be the same setup. So I'm going to go from 0 to the right, from a to 1 of this x to the negative 3 dx. Yeah, same type of problem. So what's going to end up happening here is I'm going to get the limit as a approaches 0 to the right. Antiderivative of x to the negative 3 is going to be negative 1/2 x to the negative 2 from a to 1. Okay, it's going to give me a approaches 0 to the right. Plug that negative 1/2 out there, and I'm going to get 1 to the negative 2 minus a to the negative 2. So now, got to be careful here. A lot of people just make this mistake and just think that, oh, it's going to be negative 1/2. Be careful. So this is definitely going to give me a 1 minus 1 over a squared. Did not plug in my 0 to the right. What happens when you just do a direct plug in a 0? Well, in this problem, it worked out nicely. I can just plug in a 0, boom, I'm good. I'm going to get some issues here. I'm not allowed to just plug in a 0, so I have to plug in a 0 from the right. When I plug in a 0 from the right, I'm going to end up getting a really, really high value. So like plug in like a 0.1. So I'm going to get like 1 over 0.1 squared, which is a number over a tiny number, which is actually going to give me an infinity. So I'm going to get negative 1/2, 1 minus infinity. Well, that's undefined. Okay? So this is going to diverge. I can't spell diverge, apparently. This problem right here is going to diverge for us. So just be careful on these. This is why it's important to follow all the way through using a limit notation because we couldn't plug in 0 here. So it was going to diverge All right, a couple more problems. Same idea here. So in this problem right here, we can plug in a 0. That's totally fine, but what can we not plug in? Well, we can't plug in a 27. So I'm going to integrate from 0 to b of this 27 minus x to the negative 1/3. Limit as b approaches 27 from the left, because I want to go on the left side. If it's a top bound, it's left. Okay? So now I'm going to go through this. This one, it will require a u sub. You could just do it on a baby u sub if you wanted to, but I'll just kind of stick with the u sub here. So you can't just integrate that. Don't forget your dx, actually. So when I u sub this, I'm going to let u equal 27 minus x. du is going to equal negative dx. So negative du equals dx. So I'm going to get the limit. B approaches 27 from the left. Do my bounds in just a second. Of negative u to the negative 1/3 du. If I plug in a 0 into my u here, I'm going to get 27. If I plug in my b, I'm going to get 27 minus b, and I'll just leave it like that. I'm not going to switch it around. Okay, now we can integrate that, and we're going to get the limit. B approaches 27 from the left of negative 3/2 u to the 2/3, 27 to 27 minus b. Okay. Just hoping this is going to checking my room out, see if I have enough room to do this. So when I plug this all in, I'm going to get negative 3/2, pull that out. I'm going to get 27 minus b to the 2/3 minus 27 to the 2/3. All right. If I plug in a 27, nothing weird is going to happen. So I'm allowed to plug in that 27. So I'm going to get negative 3/2 times 0 minus, because 27 minus 27 is 0. This is going to give me a 9. Yeah, it's going to give me a 9, so this is going to end up giving me 27 over 2. Ooh, that was very crooked. So sorry. I didn't really realize that. Okay, next example. This is kind of one of the weird ones that we're going to have to look out for. Integrate from 0 to 3 of this dx over 1 x minus 1 to the 2/3. Now, you plug in a 0, you're good. Plug in a 3, you're good. So, I can just go ahead and integrate. Well, this actually has a vertical asymptote at 1. So I can't integrate because I have like a stoppage at 1 between 0 and 3. So I actually have to break this up into 2 integrals. I actually have to integrate from 0 to 1 plus 1 to 3. Because of that, I need to actually use my notation here. So I'm going to do pretty much like 2 separate problems. I'm going to have to integrate on this left side from 0 to b, limit as b approaches 1 from the left, of this dx, x minus 1 to the 2/3, plus the limit as a approaches 1 to the right, of this a to 3, dx over x minus 1 to the 2/3. So just be careful on that. This is the big part right here. After this, not so bad for integrating. Do I want to use u sub or just want to use baby u sub? I'm just thinking how I want to approach this one. Okay, so real quick side work. This is just going to help me out integrate this. This is just going to be side working like pink or magenta here. So if I were just to integrate, this is the same thing as x minus 1 to the negative 2/3. This would be a baby u sub. This would just turn into x minus 1 to the 1/3, flip that times 3 plus c. So I'm going to use that information. It's a baby u sub because the derivative of the inside is just 1, so there's no really actual u sub that's going to happen here. So I'm using this information to help me integrate. Instead of doing 2 separate u subs, I think if I just do a little bit of side work right here, I'll be fine. So I'm going to end up with limit as b approaches 1 from the left of 3 x minus 1 to the 1/3, 0 to b, plus the same exact thing, but now I'm just going to use the a of 3 x minus 1 to the 1/3 from a to 3. Okay, and now I'm actually looking like I'm in pretty good shape here because when I plug in my b, I'm going to get my limit as b approaches 1 from the left of 3 times b minus 1 to the 1/3 minus 0 minus 1 to the 1/3 plus the limit as a approaches 1 from the right of 3 3 minus 1 to the 1/3 minus a minus 1 to the 1/3. All right, I'm allowed to plug in a 1 straight up, so I'm good to go. So I'm going to be left with, on this side, just a big old 3. I'm allowed to plug in a 1 over here as well, and this is going to leave me with a plus, right? Yeah, plus a 3 to the 2 to the 1/3. And that's my answer. Okay, probably be written a little bit nicer like this: 3 plus 3, and this would be the cubed root of 2. But there you go. And this would be an answer you would not get unless you actually split it up. All right. Hey, last problem here. I'm going to try to hurry it up. I don't want to make this a long video. So let the function equal 2 ln of x and let r be the unbounded region in the fourth quadrant. So a quick little sketch here will tell us what our bounds are. So this is 2 ln of x. So that's what the graph 2 ln of x looks like. It just got stretched. So what's important to know here is that I'm going to integrate from this 0, vertical asymptote, and this is always equal to 1, by the way. Okay, so I'm going to integrate from 0 to 1 of this function 2 ln of x dx. So this problem, you just had to find the bounds, something we haven't really done too much of up to this point. So don't worry about how you get from here to here. Once you're here, we're golden. Okay. So you cannot integrate at 1 though, so you have to do the limit as a approaches 0 from the right, from a to 1 of 2 ln of x dx. If you remember, we're not allowed to integrate 2 ln of x dx. We actually have to do this one, integration by parts. So let's go through it. So reminding you how to do integration by parts. We're going to do the tabular method. So I'm going to be given plus minus, and I'm going to do ln of x, and then this is just going to be dx. Derivative is going to be 1 over x, and then I'm going to get x. And then if I multiply 1 over x times x, I can integrate that. So I'm going to be totally good. So this is going to equal, I'm going to pull that 2 out in front so I don't have any issues. So it's going to be the limit a approaches 0 from the right of 2 ln of x dx. It's going to evaluate that from a to 1 minus integral from a to 1 of 1 over x times x is 1. So it's just going to be dx. Just checking my work here. So this is going to end up giving me the limit a approaches 0 from the right of 2. Oh, this 2 should be right here as well. I almost forgot that. Ooh, because the 2 goes to everything. I could have just put the 2 way out in front, but whatever, I didn't. So it's going to be 2 ln of x minus the antiderivative of dx is just going to be x. So minus 2x from a to 1. I'm just checking my work here. Make sure that I am good to go. Okay. So this is going to give me the limit as a goes to 0 to the right of 2 ln of 1 minus 2 times 1 minus 2 ln of a minus 2a. So ln of 1 is just going to be 0. So I'm actually going to be left with a negative 2 minus. If I plug in a 0, ln of 0 from the right is actually going to give me a negative infinity value. Okay? So we're going to need to do a little bit of rewriting here because it's going to just kind of be a little weird here with this 2 ln of a. I'm just double checking all my work is correct here. Oh, yeah, no, this should be an x right here. Oh, boy. Oh, boy. Yeah, okay, I was like, this problem is not... Okay, so I forgot that x right there. So you got to plug in a 1 right there, which would be fine. You got to plug in an a right there. There we go. I was going to say, this problem does work out. That should be a 2a ln a minus 2a. I do apologize for that. I'm on a video with nobody. Nobody can catch my mistakes. So I have to actually go do a little side work here to figure out what the limit as a approaches 0 from the right of 2a ln of a is. So we're actually going to use LHOP here. So I have to rewrite it. So I'm actually going to get this to equal the limit as a approaches 0 of 2 ln of a all over 1 over a. And I'll have you do the LHOP on your own here. But when you do find this limit, you do the LHOP, do the derivative of both sides, you're actually going to get 0. So this is going to turn out to be a 0 minus 0. So my answer is going to end up being a negative 2. All right, so sorry about that. A little missing that x there, which is going to pop that a right there, which is going to change up our answer a lot. You're just going to find the, I forgot this as well. You have to use LHOP because you're going to get 0 times negative infinity. So you have to rewrite it. And when you rewrite it, you're going to have to take the derivative right here on top, take the derivative off the bottom, and then using LHOP. And then you'll be able to figure out that this is 0. So since that's 0, that becomes 0. So I'm going to get 0 minus 2 times 0, which is 0, which is why my answer is negative 2, which makes sense because the area below the curve here is negative. And that's it.